Hello, my name is Delaney Kirk, and this is Lab 5 Choose Your Own Adventure for Physics 2211. So in this lab, we were able to come up with our own experiment that accurately showed our skills and the coding principles we've learned throughout the lab. I chose to analyze the total energy of a projectile, and I used the tracker to gather experimental data, and then I used GlowScript for the computational model. The result is that the total energy was conserved, and then the paper or projectile that is thrown has both potential and kinetic energy. So two things for main physics principles: projectile motion. The momentum principle, or Newton's second law, was used to update both velocity and position with those formulas, and then kinetic energy is the energy associated with the motion of an object with the formula listed, and then potential energy is the energy associated with the height of an object. The initial conditions were a crumpled up piece of paper with the surroundings being Earth, and the position and velocity are listed as follows, along with the mass. This is the video we used that we plugged into Tracker, and then we used a point mass tracker to track the motion of that ball. And from there, we were able to input it into the code. And what I did was kind of combine physics lab 1 code and lab 4 code. So the first part is a lot of just the visualization and initialization steps. Notice the mass of the ball, the position, and the velocity. Those were gathered from Tracker. And then we set up lines to compute the kinetic and the potential energy, and the total energy is kinetic plus potential. So then we enter the while loop, and we're going to find the velocity we're going to update the velocity and the position of the ball using Fnet, which Fnet in this case is the mass of gravity, and then we find the current kinetic and potential energies, and we plot them, and this is what the visualization looks like. That yellow dot is the origin, and you can see that the projectile is moving kind of down and to the right. And then if we go to, you can kind of see that in this results page, as you notice the total energy decreases a little. And then we can look at the position. So this is the X. It's going to go to the right, so the position's increasing, and then the Y position is decreasing. There were a couple of sources of error in this lab. First was that in Tracker, it's kind of difficult to consistently track the center of the mass, and this can be attributed to human error, as I can't perfectly place that tracker dot on the same spot each time. And then the other source of error was outside forces. This model didn't account for other forces such as the drag force. The only force we included for our net force was the gravitational force. So now we can ask what if the projectile is connected to a spring? We would have to have calculations for the spring energy to ensure that that total energy is conserved. And then what if the ball was thrown up, caught midair, and then released again? What would the energy graph look like? Well, on the ascent, potential energy would start at 0 and then increase, and kinetic energy would increase. And then when caught, the potential energy would be at its max because the ball is at the highest, and the kinetic energy would become 0 because the ball is no longer moving. And then on that descent, the potential energy would decrease from its max to 0 as it approaches the ground, and then the kinetic energy would increase because originally it was at rest, and then now it's increasing as it approaches the ground. But thank you so much for listening. I had a really fun time creating this lab, and I hope you enjoyed it.